One of the major challenges in urine drug testing is a practice involving the tampering with a urine specimen in the attempt to revert from a positive result. All urine drug testing samples are prone to tampering. However, criminal justice tends to get more creative. This is because most criminal justice testing is abstinence-based, and so the attempt to tamper or substitute is increased over a client that has expected results, for example, a prescription drug that must be present. We combat this with validity testing and observed collections. Validity testing is also sometimes referred to as specimen integrity testing. In medication adherence and abstinence-based testing, there are two areas of critical concern. This is the detection of non-prescribed drugs and illicits and the potential of false negative results. Let's start by going over some common terms we will use today. Specimen validity, sometimes referred to as specimen integrity testing, is performed on a urine sample to detect dilution, substitution, and/or adulteration. A dilute is a specimen with a creatinine value below acceptable determined limits, below limits that would be consistent with normal human urine ranges. Substituted is a specimen with creatinine levels below dilute, that is suspicious of not being urine at all. Adulterated is a specimen which has an abnormal pH or contains nitrite, butyraldehyde, or other oxidizing substances and/or chromate. And finally, invalid, which is often interchangeable with adulterated to reflect a sample not meeting validity criteria. First, let's talk about some very common myths on the internet on how to beat a drug test. Detoxifying agents, usually containing caffeine and diuretics, are said to boost metabolism and therefore decrease the drugs in the body faster. This is a false concept. The minor contribution of a potentially increased metabolism is not significant enough to detox drugs faster from the body. Then there is the claim that taking large amounts of common muscle building compounds such as creatine will increase your creatinine level. This is also false. Several studies have shown that these two are similar in name, but the metabolic contribution isn't there. In fact, several studies have shown taking large amounts of creatine can actually cause liver and kidney problems. Niacin. Not only is this completely false, but it is dangerous. There are many cases of individuals having kidney failure, liver failure, and other effects from overuse of niacin in an attempt to beat a drug test. Golden seal. This actually comes from a 1900 novel and is completely science fiction. Why anyone latched onto this science fiction, we will never know, but drinking golden seal will not work. Baking soda. On the internet, it says 1 to 3 tablespoons followed by a gallon of water 1 to 3 hours before the test. Well, not only is this obvious, it is the water that dilutes the urine that allows for the passing of the test, but this is very dangerous as well. The base of the soda reacts with the acid of the gastric juices in the stomach, creating carbon dioxide, and can lead to gastric perforation or a ruptured bowel, which in layman's terms means a hole in the intestine and/or stomach. According to a recent publication in 2019, the most common form of specimen tampering is by sample dilution, followed by the addition of oxidants, and then substitution. We will dig into each of these categories in further detail. Let's begin by understanding the methodologies out there to identify tampering. Most common in the lab is the immunoassay screen on a high-speed, high-throughput automated analyzer. These are preferred methods for tamper detection because they are quality controlled and calibrated assays. There are multiple adulterants available that can be quickly ran cheaply. There are also point-of-care screens and dipsticks available from multiple manufacturers to capture these results. They are a great alternative when you want a quick result immediately after collecting the sample versus waiting for it to come from your lab. Some of these dipsticks can provide more esoteric tampering tests than your lab immunoassay analyzers. That means there are some strange and rare adulterants that standard testing may not pick up, and you could purchase a dipstick to look for these more strange adulterants. Finally, spot tests. This category represents, for example, a surfactant adulteration, commonly known as soaps and detergents. This is performed using basic chemicals in the lab, such as methylene blue. If the sample turns a certain shade of blue, it represents some soap or detergent was added. In specimen validity testing, the two main goals are to catch dilution and substitution. Dilution is to intentionally or otherwise drink large volumes of liquids, thereby diluting the drugs down to below cutoff, resulting in a negative test result. In substitution, there are multiple ways. There are additives meant to mask or destroy the drug present, bleach, eye drops, baking soda, soap, drain cleaner. There is synthetic urine, which is often purchased online. There is using another individual's assumed clean urine. And finally, the complete substitution of the sample with another liquid altogether that is not urine, such as water or juices, in an effort to mimic the appearance of the urine sample. All of these examples can be combated with the same testing: creatinine, specific gravity, pH, oxidants, nitrites, chromates, soap tests, and the uric acid test, to name a few we will talk about today. Let's take each of the common validity tests one by one. It is important to note as we go through these that every lab and/or testing agency may have slightly different requirements on the extreme ends of acceptable ranges, but they are all based on the same expectations and sciences. pH. The urine is comprised of water, salts, and waste products from the kidneys. The balance of these compounds affect the urine pH, which is a measurement of how alkaline or acidic the sample is. Is it basic or is it acidic? Normal human pH can fluctuate throughout the day, but has well-defined reference ranges found in literature. This gives us the ability to easily identify if a sample has been tampered with. Typical human urine pH has an average of about 6, with the normal range being between 4.5 and 8.9. Specimens outside this range at either below or above are considered adulterated or invalid, indicating tampering. There are, however, some scenarios that could increase or decrease a sample's pH. A higher pH can come from a urinary tract infection, kidney failure, or sometimes bad storage conditions. Samples that have been stored too long at higher temperatures can have an elevated pH. This is one of the reasons it is recommended to keep specimens in a cool place if you cannot immediately send them to the lab. Lower pH can occur from diabetic ketoacidosis, starvation, and diarrhea. These physiological scenarios would be quite rare. Next is specific gravity. Specific gravity is a measurement of particulate matter in urine as compared to water, and it measures the dissolved particles within the sample. This again is going to be your salts, metabolites, mucous membranes, etc., found in urine and not found in water. Specific gravity is compared to a value of 1, which is that of water. An increase in urine concentration will result in higher specific gravity, and a decrease in concentration would result in lower. Often, clients choose to only measure specific gravity if the creatinine of the sample is considered dilute. They would use this as a secondary marker to confirm dilution, which we will speak more on in the next slides. Again, normal human specific gravity can fluctuate throughout the day, and we have well-defined reference ranges that give us the ability to easily identify if a sample has been tampered with. Typical human urine is normal between 1.003 and 1.020, and is considered invalid if below 1.002 or above 1.021. Some scenarios resulting in a higher specific gravity include dehydration and renal dysfunction. A lower specific gravity will be from an excess of fluid intake, renal failure, and diabetes insipidus. Let's move to adulteration and substitution. Here are some examples of common items used to adulterate and substitute. Many are found around the house or easily ordered online. I have also listed what the effects might be to the urine sample and what that would look like on a test. Clorox, baking soda, Drano are all very basic, so would bring up the pH of the sample. They all have higher specific gravities than urine and would also be detected using a general oxidant panel. Juices would bring down the pH since they are acidic. And salt, while it may not affect pH, would have an increase on specific gravity due to the added particulate matter. As mentioned previously, substitution and adulterations can occur in multiple ways: by adding some liquid or agent with the intent to destroy or drug any drug present within the sample or mask the drug from testing technologies, by replacing the sample with a synthetic urine that is easily purchased, by using another individual's clean urine. This can be from a friend or a family member, perhaps even purchased. And finally, the addition or total substitution of some other liquid, such as juice or toilet water. So how do we combat urine substitution and adulteration? We talked about using pH and specific gravity, but what else can we do to detect tampering? Let's take urine substitution with authentic clean urine. This is definitely the most difficult to catch. One thing I like to tell people when you are combating substitution of another person's authentic clean urine is to look for multiple tests in a row with the same creatinine. Often people will get one sample, dilute it a little, and use that same sample or lot multiple times in a row. If you see multiple samples with the same creatinine, you should be suspicious. It is physiologically impossible to reproduce the same creatinine level multiple times in a row. For synthetic urine, it is a little easier. We have a test for that, and that is uric acid. Uric acid is produced in every human by the metabolic breakdown of purine nucleotides. Purines are natural substances found in foods such as mushrooms and anchovies. They are also produced naturally in the body during the breakdown of cells. While some synthetic urines contain uric acid, the majority available do not. So it is the absence of this compound in the sample that confirms the use of synthetic urine. Before we move on to creatinine, because it is the most important test in determining tampering, let's talk about some other commonly ordered tests. General oxidants detect a general class of well-known oxidants, which include, to name a few, bleach, iodate, stealth peroxidase, urine luck, chromates, glutaraldehyde, and soap. Nitrites and chromates are both generally identified in the oxidant panel, but can be more specifically calibrated in additional specific testing. Some examples of nitrites include the well-known clear adulterant, and in chromates, the well-known urine luck product. What is important to note is there are some rare scenarios where a sample may have elevated nitrite levels naturally. This could be from certain pathological conditions, certain medications, microorganisms, and sometimes in the presence of blood in the sample. So be sure to take a closer look at individuals with elevated nitrites before taking adverse action. So let's move on to the most complex but the most important test in combating sample tampering, and that is creatinine. Creatinine is a chemical waste molecule generated from muscle metabolism through the kidneys. It is not affected by diet or normal physical activity and is produced at a constant rate for every individual. The concentration of creatinine is highly dependent on the individual's hydration status. So well-hydrated individuals will have lower levels, while dehydrated individuals will have higher levels of creatinine. These levels can vary tremendously within one individual and can vary tremendously person to person. So it is not appropriate to compare creatinine levels side by side between individuals or even with one individual. Most normal urine samples have a creatinine value between 20 and 350 milligrams per deciliter, with less than 2% of the normal population producing levels less than 20. I want you to remember that number as we move forward. Dilution is the most common method used to avert positive drug testing result. And why is that? Well, it's because it works, but we have tools to combat that. How is this done? By consuming large amounts of liquids, i.e. water, soda, coffee, prior to collection. This is normally about 2 or more quarts in the 1 to 2 hours prior to collection. By adding liquids to the sample post-collection, like toilet water, juice, tap water, or even by taking diuretics, which can help to dump excess liquid from the body. Why is this done? Because diluting a sample, intentionally or otherwise, decreases all compounds in the urine, including drugs and metabolites of interest. So how do we beat it? By measuring creatinine concentration, we can measure urine concentration and understand an individual's hydration status. So in this example, the donor drank 3 quarts of water 1 to 2 hours before their test, resulting in a creatinine that was 10 times more dilute than normal, which means all drugs within the sample are also 10 times more dilute, potentially lowering all drugs below the test cutoff. It is important to note, all drugs, with the exception of parent ethanol or alcohol, are diluted to the same degree as creatinine. Also, specimens that screen both negative and dilute should be considered invalid results. Positives are still positives, but negatives are not necessarily negatives. Now, why is that? Because as we mentioned before, a diluted sample gets that level down lower than the cutoff, giving us a false negative. But a person could take a super high concentrated sample and dilute it down and still have a level above the cutoff. So that backfired for them because now we know 2 things. They are positive and they intentionally tried to subvert the drug testing. I like this graphic because I think it represents a dilution effect well visually. You can see both specimens have the same amount of drug in them, but the one on the right is more diluted. If I was to take a portion of this sample on the right, it would have less drug in it than the one on the left, therefore potentially getting a negative sample below the cutoff. A specimen is considered dilute if it has a creatinine value of less than 20 milligrams per deciliter. A specimen is considered substituted if it has a creatinine of less than 2 and a specific gravity of less than 1.001 or greater than 1.020. Why is below 2 considered substituted? Because studies have shown that the human body does not physiologically produce a creatinine at levels lower than 5. Here's a study we conducted in our laboratories in 2017. Over 42,000 samples were evaluated for creatinine values, and you can see here that less than 3.6% were less than 20 milligrams per deciliter. So thinking back to our previous slide on the normal population, we said that less than 2% were below 20. Why the difference? This is because our population studied actually included individuals with intentional dilutions. The normal population, not associated with a drug test, has no need to intentionally dilute. So the number of dilute samples below 20 is lower. This number is important to understand when faced with a donor that claims dilution wasn't intentional. Is it possible? Well, yes, there is that 2% population, but is it probable? No. Under 20 milligrams per deciliter is likely intentional dilution. Dilution can also dilute out intended positives. In this example, you see the prescription for Suboxone should result in this test being positive for buprenorphine and naloxone, but you can see it is negative. If we look at the creatinine, this sample has been diluted out and all drugs within have been diluted out to a level below the cutoff, even intended ones. I suspect this was intentionally diluted due to this here. This sample before it tested positive for benzoylecgonine, which is the metabolite of cocaine. The creatinine is 24, within limits, but barely. So this person was probably trying to dilute out that cocaine. Let's look at some additional examples on how the reporting of specimen tampering might look. Here we have a dilute negative sample. The creatinine is less than 20, but above 2, and the specific gravity is below range as well at 1.002. We should consider this result as invalid because any drugs potentially present could be diluted down below the cutoff. This could be from a large volume of liquid consumed prior, or it could be used from a small amount added to the sample. Here's an example of a dilute positive. The creatinine and specific gravity are both below range, but the THC metabolite is still positive. This sample was likely tampered with, but it didn't work for the THC. However, there could have been other drugs present that were diluted under the cutoff. So here again, we know two things. They are positive and they likely tampered. Here's a sample that was substituted with some other liquid than urine. The creatinine and specific gravity are out of normal human range. These values are consistent with what you might see water look like, a pH of 7.4 neutral with no creatinine and a specific gravity of 1. These two values are not consistent with either a dilute or a substitution. We have a dilute value of creatinine, but a specific gravity of water. Since these two don't typically occur together in either specific scenario of dilution or substitution, it falls into the category of invalid. This sample was likely tampered with. Finally, here are some quick examples of what some other validity testing would look like. Up top, we have an acidic pH of less than 4.5, resulting in an adulterated invalid result. Likely, a small amount of something acidic was added, perhaps some vinegar. Next is a failed oxidant at a level of 300 micrograms per milliliter. Everything else is normal, but oxidants were detected. This might be consistent with glutaraldehyde or urine luck. And at the bottom is nitrites with a value greater than 500 micrograms per milliliter, which might be consistent with something like the clear product. Now we ask ourselves, what can I do to beat a cheater? I know what the lab is doing, but how can I make a difference? Conduct observed collections. The #1 way to prevent adulteration and substitution is to perform an observed specimen collection. This usually occurs by same-sex visual collection. Make sure the sample never leaves the eye line of the donor or collector. Have the donor empty their pockets, remove outerwear, purses, etc. Have them wash their hands with water and not soap to ensure there is nothing on their hands or under their nails to prevent them from dropping something into the sample. Inform the donor that the collector must visually observe the urine leaving the body. Be careful to look for any strings, pouches, or conspicuous items attached to the body. Always seal the sample in the presence of the donor and have the donor acknowledge this was indeed their sample and sealed in their presence on the form and the tamper evidence seal. What if we don't have people or the facilities to perform an observed collection? What else can we do? Drop blue septic dye in the toilet water. That way, even if they attempted to dilute with toilet water, it would be automatically obvious because the sample would now be discolored. Utilize a randomized matrix like oral fluid. Randomized test matrix is a great tool if you are suspicious of tampering. Oral fluid can be a superb alternative to urine because it is always an observed collection and is therefore almost impossible to adulterate, and is not subject to dilution effects like its urine counterparts. So drinking copious amounts of fluid will have absolutely no effect on this testing. A person can prepare all they want to tamper, but utilizing this test matrix eliminates the possibility of adulteration. Which brings me to randomization. Randomization of drug testing is critical in combating sample tampering. A true randomization program will help to ensure the individual did not have the time to prepare to subvert the test. Make sure your randomization program is capturing the right individuals at the right time and the right testing. Next, pay very close attention to specimen temperature at collection. A sample should be between 90 and 100 degrees Fahrenheit immediately after collection. If the sample is not, discard it and ask the individual to provide an additional sample. Visual inspection. Shake the sample around and see if it bubbles. Proteins in authentic human urine bubbles when agitated, so the lack of bubbles when shaken is a sign it could be a substitution. Finally, check for unusual colors or odors. What else should you know? Well, so here are some final thoughts. Tampering usually targets urine drug screening technologies and not the confirmation technologies. Often, LC-MS testing will still provide valid positive results on tampered samples. The guidance from the Substance Abuse Mental Health Services Administration recommends the minimum validity testing of creatinine, specific gravity, and pH on all specimens. Any one of these, pH, specific gravity, creatinine, adulterants, etc., can be invalid to make the entire specimen validity a failure. Finally, specimens that fail validity should be considered non-negative samples. Positives are still positive, but negatives are not negatives.